Hello everyone, this is Palak Jain, Assistant Professor in Arya College Ludhiana. Today I am going to present on the topic data models. So first of all, what is data model? If we talk about the data models, so first of all, what is data models, right? So the model is a representation of reality, real world objects and the events under association. So, as we know that the models are the cornerstone of design. As if we take an example, then we can see that the engineers build a model of the car to work out any details before putting it into production. So, in a similar way, the system designers develop the models to explore the ideas and to improve the understanding of the database designs, right? So, this is the concept of model. Now, what is data model? It can be defined as an integrated collection of concepts for describing and manipulating the data, relationship between the data, and the constraints on the data in the organization. Now the data model has three components. First one is structural part, second is manipulative part, and third one is integrity rule. First of all, the structural part, it consists of the set of the rules that according to which the database can be constructed. Right. Second one is manipulative part that defines the types of operations that are allowed on the data, like the insertion, deletion, updation. So these are some of the operations that we can perform on the database, right? Third one is the integrity rules. That is some of the rules that ensures that the data is accurate, right? So these are three components of the data model. Now we have the categories of data models. So the purpose of the data model is to represent the data and to make the data understandable. So in this way, it can be categorized into three main parts. First of all, the object-based data model. Second one is physical data model. And third one is record-based data models. Right. First is object-based data models. So these are the models that use the concepts of entities, attributes, and the relationships. Right. Before that, we come to know about entities, attributes, and relationship. First of all, what is entity? Anything that anything we can say that anything about which the data is to be collected or stored. For example, if we take an example that if we want to collect the data of the students, then student is an entity about which the data are to be collected and stored, right? So second one is attributes. This is the characteristic of an entity. Like if we take an example of student, so the attributes are name, roll number, class, or anything related to the student. So these are some of the attributes of the entity student. Third one is relationship. It is an association among entities, right? So we have four main relationships, that are one-to-one relationship, one-to-many, many-to-one, and many-to-many. These are four types of relationships that are existed, right? So some of the more common types of object-based data models are anti-relationship and object-oriented. As the anti-relationship model that has emerged as one of the main technologies for modeling the database designs, and the object-oriented data model that extends the definition of the entity, that not only include the attributes that describe the state of object but also the actions and behavior, right? So second one is physical data model. These are used to describe how the data is stored in the computer, right? Representing the information such as record structures, record ordering, and access path. So this is physical data models. Third one is record-based logical models, as these are used in describing the data at the logical and the view level, right? So it is further divided into three main models, that is hierarchical model, network model, and relational model, right? We will describe these three models in detail. First of all, hierarchical model. This is one of the oldest database model, and this model is like the structure of the tree with the records forming the nodes and the fields forming the branches of the tree. So this was dating from the late 1950s, and this journal shape of this model is like an organizational chart in which the node on the chart that represents a particular entity and the parents and the child terms are used in describing the hierarchical model. So basically this model is also known as an inverted tree. It is basically like a tree, and a tree is a data structure that consists of the hierarchy of the nodes, right? So this, the highest level, that is called the root node, and there's so many operations that we can perform in the hierarchical model, that is insert operation, update operation, and delete operations. So this is an example of the hierarchical model in which we can see it is like a tree structure in which journal manager, it act as a root of the tree, right? Or we can say that it act as a node of the tree, right? So deputy general manager, as there are four entities of the deputy general manager, as we can see in this diagram. So these are the child of the parent general manager, right? After that, first deputy general manager has further two child, that is sales department and advertisement department. For the sales department and advertisement department, the parent is deputy general manager, right? So this is like the tree like in which one is a node of the tree and other are the branches of the tree, right? This is further example of the hierarchical model in which we have great grandparent, that is the node of the tree, and further it has grandparents, then children. As we can see in this example that a parent has a multiple child but a child has only one parent, right? So it is arranged in the top down structure basically, right? So here are some of the advantages of the hierarchical model. First one is simplicity, as the records are related in the form of parent-child relationships, so we can perform the ways operations in the tree-like structure, which is easy and simple. Second one is data security, as we know that each child segment can be linked to only one parent, right? So if we want to reach at particular child, then we have to pass through the parent in this model. So it provides a data security which is enforced by the DBMS, right? Third one is data integrity. As we know that the parent-child relationship between the various records in the hierarchical model, so it represented by the relationship, or we can say the link, right? So each child segment, it can be linked to only one parent. So that promotes to data integrity. Then we have efficiency, as we know that the hierarchical database model is very efficient because the database contains a large number of one-to-many relationships. So these are some of the disadvantages of hierarchical model. First one is database management problem. As if we want to change in the database structure of the hierarchical model, then you need to make necessary changes in application programs that access the database. This is a major problem in the hierarchical model. Second one is a lack of structural independence, as when the changes to the database structure does not affect the DBMS ability to access data, then the structural independence exists, right? Third one is operational anomalies, as we have insert anomaly, update anomaly, deletion of anomalies. So these are some of the anomalies that are existed in the hierarchical data model. Fourth one is implementation limitation, as we can see that most of the common relationship that do not conform to the one-to-many format required by the hierarchical model. So if we want many-to-many relationships, which are very common in real life example, so it is difficult to implement in the hierarchical model because it supports only one-to-many relationship, right? Second model which we will discuss is that is network model. So network model that replaces the hierarchical tree with a graph, thus allowing more journal connections among the nodes. So it was developed to overcome the limited scope of the hierarchical model. Here the multiple parent-child relationships are used, right? So this model uses a network structure, which is a data structure that consists of nodes and branches. right? So this in this model we have directed graphs that are used instead of tree structure. It can handle many to many relationships, right? So it can handle one to one relationship, it can handle one to many and many to many relationship among the entities. So basically it act as a, or we can say that it uses a network structure, like, okay. So we have this example in which S1, S2, S3, these are three suppliers, and P1, P2, P3, P4, these are some of the part that we can supply, that is supplied by the S1, S2, S3, three suppliers. So this is a diagram of the network in which every supplier is linked with the parts through the pointers basically, right? So if, for example, if the supplier S1 stops the supply of part P1, as we can see in this example, it supplies, right? If the supplier S1 stops the supply of part P1 with a quantity 250, then the model is modified without affecting the P1 and S1 information, right? So here are some of the advantages of network model. First one is the capability to handle more relationship types. As we can see in this model that it can handle one-to-many and also many-to-many relationships, which helps in modeling the real life situations. Second one is ease of data access, as it is easier and it is flexible than the hierarchical model. Third one is data integrity. In the similar way as a network model, it does not allow the member to exist without an owner. So a user must first define the owner record and then the member record. This will ensure the data integrity. Then we have data independence, as it is better than the hierarchical model in isolating the programs from the complex physical storage details. So it is data independent. Fourth one is database standards. As one of the major drawbacks, as we can see in the hierarchical model, was the non-availability of universal standards for database design and modeling. But this model, that is network model, that is based on standard formulated by the DBTG, so which is augmented by the NSI or SPARC, that is American National Standard Institute or Standard Planning and Requirement Committee in the 1970s. So it included the DDL, that is data definition languages, data manipulation languages. So these are some of the languages, and this model is based on these database standards. So sometimes we call this network model as the DBTG model, right? So these are some of the disadvantages of the network model, as we have system complexity, as because the records are maintained using the pointers, so whole database structures become very complex sometimes. Second one is operational anomaly, as we can suffer from the insertion, deletion, updation operations anomalies in this also, as there are a lot of pointers in this. So its implementation is very complex and complicated, right? Then we have absence of structural independence, as the data access method in the network data model is navigational system. So it makes the structural changes to the database very difficult in most of the cases and impossible in some of the cases, right? Then we have third model, which is relational model, which is widely used in real life objects. So it is in the form of tables, and we have three major components that is used in the relationship model. In relational model, first one is the set of relations and the set of domains that define the way that can be represented the data, that is data structure. Second one is integrity rules that define the procedure to protect the data, that is data integrity. And third one is the operations that can be performed on data, that is data manipulation. So some of the characteristics of the relational database are that whole data is conceptually represented as a orderly arrangement of data into rows and columns, which is called a table. So in this relational database, we can call the table as relation, right? So all the values in the relational database are scalar, and all the operations that are performed on the entire relation and result is an entire relation is this concept is known as closure, right? So some of the basic terminology that we can use in the relational models are, as I have already told you, that we can call the table as a relation. So the columns in the tables, it can be called as attributes, and the rows that are called as tuples, right? So as we can see that there are three columns: employee code, name and year. These are called attributes, and there are four rows that we can call it as a tuples, right? Then we have another term, that is cardinality and degree. Now, what is cardinality of the relation? That is the number of tuples in any table that determine its cardinality. For example, in this table we have four tuples, so its cardinality is 4. In the similar way, we have degree. The degree is number of columns, or we can say the number of attributes. As we can see in this table, we have 3 attributes, so the degree is 3, right? Now we have domains. So what is domain? It specifies the kind of data that is represented by the attribute. So it is a set of all the possible values that an attribute may validly contain, right? So if we take an example, then we can see that we most of the people are confused with the data types, right? There's the domains and data types are same, but it is inaccurate. As if we take with an example, that number, it is a data type, but the age, it is a domain, right? So these are some of the examples of the domains. Then we have body of the relation. As the body of the relation consists of unordered set of zero or more tuples. So some of the major concepts that are used in the body of the relation are: first, the relation is unordered. Second, a relation with no tuples still qualify as a relation. And third one is the relation is a set and the items in the set are uniquely identifiable, right? These are some of the three major points of the body of the relation. And for the table to be qualified as a relation, then each record must be uniquely identifiable and the table must contain no duplicate records. Then we have keys of the relation, as it is a set of one or more columns whose combined values are unique among the occurrences in the given table. So some of the major keys are, first of all, primary key, as it is an attribute or a set of attribute of the relation which possess the property of uniqueness and irreducibility. Like for example, if we have two tables, that is S table and P table, right? In S table we have supplier number and in P table we have primary uh, part number, which is unique in their tables, right? So supplier number in S table, it acts as a primary key, and the part number in P table, it acts as a primary key. If we combine both the tables, that is supplier table and part table, right? In S table and P table, then we can call it as SP table, for example. Then the combination of supplier number and the part number, because these two are unique in their own table. So when we combine these two tables, that is SP table, then the combination of the supplier number and part number is also a primary key. That is a combination of both. It is a primary key, right? Which is unique. Then we have foreign key, which is the attribute of the table that refers to the primary key of some another table, right? So the foreign key permits only those values which appear in the primary key of the table to which it refer to, or may be null. For example, serial number in the SP table, that refers to serial number of S table, which is a primary key of S table. So we can call the serial number in SP table is the foreign key, right? As we can take the serial number of S table as a primary key, but for the another table, that is SP table, same serial number act as a foreign key because it is a primary key in another table, that is S table, right? This is an example of foreign key. So some of the advantages of relational model are, that is structural independence, as the changes in the database structure that do not affect the data access, right? So when it is possible to make changes to the database structure without affecting the DBMS capability to access the data, then it can be called as a structural independence, right? Second one is simplicity, as we can see that it is in the form of tables, so it is very easy and simple to design and implement even, right? Then we are having some of the disadvantages of relational model, but the drawbacks of the relation model, it could be avoided if the proper corrective measures are taken, right? So first of all, the major limitation of the relational model is that the limited ability to deal with binary large objects. The binary objects like images, email messages, documents, spreadsheets, these are some of the example of binary large objects, right? So second one is mapping objects, that can be very difficult skill to learn, right? Third one is hardware overheads. Fourth is ease of design, that can lead to bad design. For example, if we choose very easy design, that it looks very simple or it is very easy, but it can sometimes lead to a bad design also, right? So the major disadvantage is that the relational model that is not suited for the large databases. If we use it for the large databases, we cannot use the relational model because it's not suitable for that, right? So we can discuss about three models: hierarchical data model, network data model, and relation data model. So this slide shows about the comparison of data models. As in the hierarchical data model, the relationship between the record is of the parent-child type, and in the network, it can be expressed in the form of pointers, and in the relation, it can be represented by the relation, right? Second point is in the hierarchical data model, as many-to-many relationship cannot be expressed. In network, many-to-many relationship can also be implemented. And third, many-to-many relationship can easily implement it. Right. So third point is in the hierarchical data model, it is simple, straightforward, and the natural method of implementing the record relationship. Network data model, that is very complex due to the use of pointers, and relational data model, that is very easy through the use of keys, composite keys, right? So fourth comparison is that in the hierarchical data model, we can use some of the or we can say that we can use this model when we have some hierarchical character in the database, right? In the network data model, it is useful for representing such records which have many to many relationships, right? And in the relational data model, it can be useful for representing most of the real objects because there is a relationship among them, so it can be used, right? So these are some of the comparisons of the data models. Now we have discussed all of the models as a hierarchical model, network model, and the relational model. Now the question arises which data model to use, right? So we can choose that type of model which depends on three factors. First of all, the organization's primary goals and requirement. Second one is the volume of daily transactions that will be done. And third one is the estimated number of inquiries that will be made by the organization. Like if we want which type of model that best suits an organization. So these three factors are we can say that these three factors are mostly important for an organization to choose a model, right? So among the traditional data models, as the widely preferred one is a relational data model because this model is used to represent the real life objects, real world objects, and the relationship among them. And the security and the integrity in this model can also be maintained, right? So this model is used widely as compared to other models, right? Thank you so much.